Science is based on reproducible research. Progress is possible in science when a second researcher can reproduce the results of the first researcher. The challenges have been that not all of the information and data required to do the research may be available. For reproducible research to be possible, the original input data must be available, the original output data must be available, the analysis workflow must be available. If the data and workflow from the original analysis can be shared, then re-execution of the workflow should create a result set that can be compared with the original results. It should also be possible to modify the workflow, execute the new analysis, and compare results with the original analysis. Data grids provide mechanisms to manage and share workflows as well as data files, enabling reproducible research. It is possible to create a workflow that automates the execution of an analysis. The workflow would apply the following steps: retrieve the input data from data repositories, transform the input data as needed, execute the analysis, save the input and the output results, generate diagnostic output and visualizations. Workflow structured objects in the data grid link the input files and output files to the workflow. This automates step 4. The researcher still has to define which input to use and save the algorithms that transform the input and do the analysis as operations controlled by a rule. The rule can then be saved in the data grid. Given a standard workflow, a data processing pipeline can be built. It is possible to write a rule that detects the presence of a new file in a collection, applies an algorithm to generate derived data products, and stores the data products in a collection. The processing steps are automatically applied, the output is automatically stored, and the workflow guarantees the application of the processing to every file in a designated collection. Application domains that build upon processing pipelines include genomics, automated sequencing of genomes, astronomy, automated extraction of stellar objects from images, hydrology, automated watershed analyses, and preservation, automated creation of archival information packages. Curation is the process of creating an archival version of a digital object. The steps include organizing provenance and description information, creating standard forms for the data, and creating the archival record. However, curation can be an ongoing activity. A standard challenge is the management of derived data products when the original input data are changed. NASA curates sensor data received from satellites. In the process, NASA generates 4 levels of data products. Level 1 is the original sensor or image data. Level 2 is the calibration of the sensor data. Level 3 is the conversion to physical variables, and level 4 is the projection onto a grid. When the sensor is recalibrated, levels 2 through 4 of the derived data products should be automatically regenerated. The original derived data products are incorrect and should be replaced. If the workflows track the provenance of each prior processing stage, a change to the output of one stage can trigger reapplication of subsequent stages of the processing pipeline. The data management system can automate curation of a data collection. Take 7 minutes and complete exercise 54. Write a rule that applies a periodic procedure. Implement the periodic addition of information to a manifest as files are added to a collection. An example is in Chapter 7.7 of the Policy Examples Workbook. Convert the example to a periodic rule that runs weekly. Check whether the file was added in the prior week, then write information to the log file. Please load your rule file into the lifetime library in the sub-collection class INLS 624 by the end of today's class.